Hello, everyone. We are a team of researchers from Penn State. I'm Yuan, and I will share with you our paper, AutoML in the Wild, Obstacles, Workarounds, and Expectations. Automated machine learning, or AutoML, is a novel concept for automating the whole machine learning pipeline without or as little as possible human intervention. By liberating users from repetitive machine learning tasks, such as data preprocessing, parameter tuning, and feature selection, AutoML empowers citizen data scientists to perform machine learning tasks. Thus, AutoML is believed to be the driving force of democratizing data science. In recent years, we have seen a growing number of AutoML platforms developed. However, the adoption of AutoML is slow and limited. What are some of the challenges to incorporating AutoML in real-world settings? Previous studies have examined related questions, but the focus is on the role of users as data scientists within a standard computational pipeline and machine learning workflow. However, in complex real-world settings, the concrete data science tasks are defined and executed by users with varying roles, interests, and background. And users may face a variety of issues beyond AutoML's functionality, and they often define their goals according to complex situations and accomplish the goals through cross-functional collaboration. Thus, in our study, we want to examine how users adopt and use AutoML in a variety of heterogeneous, specific situations. Specifically, the study interested in what are the perceived AutoML limitations and how do users exercise user agency in developing various workaround strategies. We conducted semi-structured interviews and recruited users who have hands-on experience with AutoML in different domains. Through convenient sampling, we recruited 19 participants who span a diverse range of domains across healthcare, finance, human resources, technologies, and academic research. The majority of our participants are based in the US, with one based in China and one in Kenya. The interviews were conducted remotely, varying from 35 to 60 minutes. We find three primary limitations of AutoML. The first one is lack of customizability, and the second one is lack of transparency. The third one is privacy concerns, which I will detail in the following slides. Specifically, participants often find lacking the capability to handle context-sensitive tasks. One common workaround is to contextualize the input data by adding context hints, so that AutoML is able to utilize such additional information to generate context-specific machine learning models. Another workaround is to gather and incorporate domain knowledge into AutoML's optimization objectives. AutoML's lack of customizability is also manifested in its limited support for uncommon data types. Correspondingly, participants often opt to build their own AutoML tools. Several participants also shared their struggles with evaluating and validating AutoML's outcomes. To cope with such transparency issues, one common workaround is to manually validate AutoML's outcomes using self-selected metrics or checking their backward compatibility with existing machine learning solutions. In addition, the process of how the models are found remains fairly vague too. To work around this limitation, participants resort to manually tracking AutoML's learning curves or compare the differences among multiple runs of this process under varying settings. Many participants also recognizing the importance of visualization, not only for understanding AutoML's inner workings, but also for communicating AutoML's outcomes to internal and external parties. We also find users voice privacy concerns over AutoML platforms, which has yet to be reported in the existing literature. One straightforward workaround is to limit privacy leakage at its root. Another workaround is to proactively apply privacy-preserving techniques such as black box optimization and federated learning. In addition, delegating to legal regulations also help users clarify their responsibilities and secure their data from a legal perspective. Lastly, participants turn to trustworthy platforms to preserve data privacy. However, participants reflected contrastive views toward the trustworthiness of cloud-based AutoML platforms. Some participants raised concerns about privacy risk of using cloud-based AutoML platforms. Other participants trusted such platforms because they believe these large companies are better positioned to protect data privacy, given their plenty of infrastructure and personnel resources. We also find that participants set clear performance expectations and decide how to use AutoML accordingly. Some participants acknowledge that AutoML may not produce optimal outcomes. However, as long as the results meet their performance expectations, they are willing to adopt AutoML for its convenience. Participants also strategically allocate different parts of their task to AutoML depending on the specific context, and only use AutoML for subtasks. Many participants also expressed concerns about using AutoML in high-stake contexts, such as healthcare, due to the difficulty to attribute responsibility. Taken together, our findings reveal that users actively exercise user agency to overcome three major challenges arising from customizability, transparency, and privacy. Furthermore, users make cautious decisions about whether and how to apply AutoML on a case-by-case basis. In our study, users' workaround reflect their needs to take control over AutoML and to restore user agency when facing constraints, challenges, and unmet expectations. The results also provide insights in terms of designing to mitigate the three perceived limitations. Specifically, the study calls for design efforts to support domain-specific customizability, providing multifaceted transparency, and enhancing data privacy. In addition, we also find that the need for human support in the automation process goes beyond the scope of standard data science workflow, necessitating collaborations among machine learning experts, data scientists, and domain experts for the successful adoption of AutoML. More design considerations have to be given to support cross-team collaboration within organizations. For details, please refer to our paper. Thank you so much for listening. Please feel free to contact me if you have any questions or comments.